Hello and welcome to Math 95 with Tina Graves. Today, this video, the lesson will be 6.4 out of the Math 95 book that CGCC is using, which is the section 6.4 is rational equations. Now, it's really important to notice if you just watched the lesson 6.3, which was adding and subtracting rational expressions, it's really important to notice the difference between these two sections. In rational expressions, we were adding the same thing to multiplying the same thing to the top and the bottom in order to get a common denominator. And with equations, we're going to be multiplying both sides by the same thing to get rid of the denominators, actually. Equations have an equal sign, which is what makes them different from expressions. And with these equal signs, that allows us to do something to both sides of an equation. With expressions, we only have one side, so we have to do the same thing to the bottom as we do the top. But with equations, we get to work with both sides. So hopefully this will become clear as we go through this lesson. But I want you to notice that the difference between 6.3 and 6.4, so that you know how to do each type of problem. Okay, so let's get started. Here we're going to be actually solving instead of simplifying. So the directions will say something like solve. And this first one, let's do x plus 1 divided by 2x minus x minus 1 divided by 4x equals 1/3. Okay. Here, we still want to talk about what the lowest common denominator is, just like we did in section 6.3. So what is the lowest common denominator here? We need something that 2, 4, and 3 go into, which is going to be 12. And then here we have an x, and nothing, so we need to include an x. So our lowest common denominator is 12x. All of these denominators divide into 12x perfectly, so that is our lowest common denominator. Now here, what we do with this lowest common denominator is we multiply everything by 12x. And if you want, you could think about this as 12x over 1, since we have fractions, but that's not necessary. And what we're going to do is distribute this to every term. Okay. For this first one, I'm going to write everything out exactly, and then I won't be doing that after this. So when you're multiplying by this 12x, it becomes 12x times x plus 1 over 2x minus 12x times x minus 1 over 4x equals 12x times 1 over 3. Okay, multiplying everything by 12x. In essence, what it does is it just sticks a 12x on the numerator of each term, as you can see. So now, if we've done this correctly, all the denominators should cancel out. So let's see here. We have 12x divided by 2x, so that leaves us with 6 times x plus 1 minus, and here the 12x and 4x become 3 times x minus 1, and then we have 4x over here, correct? Alright. Oops, I forgot a parenthesis. Now what we're going to do is distribute and simplify. So if we distribute the 6 and distribute the negative 3, we get 6x plus 6 minus 3x plus 3, because a negative times a negative is positive, equals 4x. Then we're going to combine like terms, so we have 6x minus 3x, which is 3x, and 6 plus 3, which is 9, equals 4x. To scroll my screen, so I don't have to write so small. Now, to solve this, I would subtract 3x from both sides. So 9 equals x. And we're done. One thing you do want to make sure is that your solution, you want to make sure that it doesn't make any of the denominators from the beginning 0, because if it does, then it's no solution. So 9 does not make any of these denominators 0. In fact, it would be 0 that would make those denominators 0. So 9 is our solution. All right, let's try another one. How about 3 over x minus 2 plus 5 over x plus 2 equaling 12 over x squared minus 4. Here we have to remember that, and you should be getting very used to this in the homework, is that you always want to factor first. If there's anything to factor, factor it. So here we can factor x squared minus 4 because that's a difference of squares. So all of this stays the same. And then we get 12 divided by x plus 2, x minus 2. So what is our LCD? Our LCD is x plus 2, x minus 2. So we're going to multiply everything by x plus 2, x minus 2. So that is going to hop to each term. Now, this time I'm not going to write it completely out like I did the last one. Let's see if we can think about it as we're doing it. So here, 3 over x minus 2 times x plus 2, x minus 2, those x minus 2's will cancel out and leave us with 3 times x plus 2. And then here, the x plus 2's will cancel out, and we'll have plus 5 times x minus 2 equals, and here the whole denominator cancels out all that, and you just have 12. Okay, if that's too much for you, feel free to write x plus 2, x minus 2 in each one of the numerators, and then cancel things out so that you can see it better. Here we're going to distribute the 3 and distribute the 5, so we have 3x plus 6 plus 5x minus 10 equals 12. And combine like terms, so we have 8x minus 4 equals 12. Now we'll want to add 4 to both sides. So we get 8x equals 16, and I'm running out of room. And divide by 8. So we get x equals 2. Now, luckily we have just enough room on the screen to see this. We always need to check and see if that is a solution, if it's okay. Now if we put 2 in here for this x, we get 2 minus 2, which is 0, and we cannot divide by 0, so x cannot equal 2. That's not going to work, so this is no solution. Now, some students get frustrated when they hear no solution, and really no solution is a solution itself. Remember that when we have an equal sign, what this means, let's scroll up to the original problem. What this means is that if we were to graph this on y1 of your graphing calculator, and we were to graph this on y2, right, or whatever y you want on your TA calculator, or whatever graphing device you have. But if you graph these two lines on the same set of on the same coordinate axis, okay, what you're looking for, they're equal when those two graphs cross each other. So what we're saying here, in that there's no solution, is that these two graphs never cross each other, or these two expressions are never actually equal, which is a solution in itself. It might tell you something very important about your equations. So don't be frustrated that there's no solution. Okay, moving on. Let's do one more of these types of equations, and then we will try some story problems, okay? So let's look at, this is actually number 82 out of the book, and it seems to give students some problems. So we will try it, because in your homework assignment, I think you have something quite like it. So, number 82 in the book. It's, I don't recall what page it's on. Anyway, you can find it. The questions has R equals R1, R2 divided by R1 plus R2. And I believe it explains in the textbook that this is a problem about resistors and the overall resistance, and then these are two particular resistors. And so you really have three variables here. And the question asks you to solve for R2. Okay? So, what do? We multiply both sides by the lowest common denominator. Here there's only one denominator, so we're going to multiply both sides by R1 plus R2. Okay, so I'm going to rewrite the problem here so we have some room. R1, R2 over R1 plus R2. And then we're going to multiply by R1 plus R2. R1 plus R2. With all these R's, I feel a little bit like a pirate. R. Okay, that might not have been a funny joke, but I think it's funny. Okay, so now when we multiply this side by R1 plus R2, those cancel out. And here we can distribute that. And R times R1, since we don't know what they actually are, and they're not the same thing, then we just write them together. R1 plus R2 equals R1, R2. Or maybe you're thinking of Star Wars, R2-D2. Anyway, so now the trick is that what we're wanting to solve for, we have it in two different spots, right? So what we do is we get one side of the equation, everything that has R2 in it. And then on the other side, we don't want any R2s. So what we're going to do is subtract R2 from both sides. Okay? That's going to leave us with R1 equals R1, R2 minus R2. So now that we have both of our R2s on one side, we can factor out an R2. So we're going to have R2, and left behind is R1 minus R. And here we still have R1. So now we R in one spot, and you can see that this is just multiplication here. So to get rid of this R1 minus R, we just divide by it. Okay, and these cancel out. So your solution is R2 equals R1 over R1 minus R. Okay. Hopefully that was helpful for you and will be helpful for your homework assignment. The last thing in section 6.4 is story problems. We have many story problems in this section, and any algebra book that you pick up will have these types of story problems in them. They're very, very famous, and they're the ones of you're in a boat and you're traveling upstream, it takes you 5 hours, and downstream it takes you 3 hours, and the speed of the current is 5 miles per hour. What's the average speed of the boat in still water, or something like that? Or maybe it's an airplane, or maybe it's a train, or maybe you're walking and jogging. But it's all of these problems that involve rates, distances, and time. Okay? So first we need to remember that rate equals, or actually usually we think of it as distance. Distance equals rate times time. So let's do that one first. Distance equals rate times time. Or we say d equals rt. Then we can solve for any variable we want. So if we divide both sides here by t, we get r equals d over t, or rate equals distance divided by time. Or we could solve for time and get time equals distance over rate. Okay? So this manipulation of this equation, you'll need to be able to do that for the homework. So let's do a problem out of the book. We want to look at problem 94 on page 451. So problem 94 on page 451. And this problem says, without any wind, an airplane flies at 200 miles per hour. The plane travels 800 miles into the wind and then returns with the wind in a total time of 8 hours and 20 minutes. Find the average speed of the wind. Okay, so sort of what we want, I like to make a little list. What we want to solve for is the speed of the wind. Don't let the word average fool you. It's not like you're going to find the speed of the wind at many different times and then somehow take an average, but what you will be finding is the average speed of the wind. Okay? And in order to show what we know, let's call this variable w for wind. Okay? Is I have this little chart that I want to make and show you that I think makes this stuff a little bit easier. And you can decide not to use it if you don't want to, but it might be helpful. So we'll put distance, rate, and time. And then this problem talks about going against the wind. Or if you have a headwind, that's the same thing. Or with the wind. And that would be the same thing as saying having a tailwind. Okay? So what we want to do is kind of read the problem again and see if we can fill out this chart. Okay? So, something else I want to tell you about is the rate. If we're talking about this plane, right? This problem's about a plane flying. And if you're going against the wind, then you're going slower, right? So it would be the plane's speed in still air minus the wind, right? And if you're going with the wind, or the wind's at your back, then it would be the speed of the plane in still air plus the speed of the wind, because the wind is pushing you faster. Okay, so let's read this problem again. Without any wind, so in still air, the airplane flies at 200 miles per hour. So now we should be able to fill out this block of the rate against the wind. So if it flies 200 miles per hour in still wind, or with no wind, against the wind, we're going to subtract the speed of the wind, which we're calling w. And if we're going with the wind, then it's going to be 200 plus w. Okay. Next sentence is the plane travels 800 miles into the wind and then returns with the wind. Okay, so it's 800 miles each way. So the distance each way we can write as 800. And then it says with a total time of 8 hours and 20 minutes. And here it's a little confusing because I have two distinct boxes. And so maybe what I'll do is I'll say that this is time 1 and this is time 2, and then I'll make myself a little note that says T1 plus T2 equals 8 hours and 20 minutes. Okay? Now here we have a little issue. We have units issue. We have hours and we have minutes. The rate of the plane is in miles per hour, so we need to change this to total hours. So 20 minutes, that is 1/3 of an hour, so we could also say that this is 8 1/3 hours. And then if you make that into a improper fraction, you go 3 times 8 plus 1 is 25/3 hours. Okay? Now we still we don't have an equation yet, but if we remember these little relationships that we had here, these guys, we have total time, so we want to use this one, where time is distance over rate. So if we go back and say, well, oops, too far. T1 is really, this is really distance over rate, right? So we can say that that is 800 divided by 200 minus W. And this is 800 divided by 200 plus W. Okay? Now we can write an equation, because we have T1 plus T2 is 25/3. T1, we have an expression for that. So we can say that 800 over 200 minus W plus 800 over 200 plus W equals 25/3 hours. Perfect. Now this is what we need to solve. The lowest common denominator here is going to be what? Let's see. We need the 3. Well, they're all completely different, right? So we need to, whoops, multiply them all together. So 200 minus W, 200 plus W. Alright, so we're going to have to multiply that by everything. Let's get over here on our page a little bit. So 3 times 200 minus W, 200 plus W, times 800 over 200 minus W plus 800 over 200 plus W equals 25/3. Awesome. Now we're going to want to distribute this to everything. You with me still? These guys can be tricky, but if you take them step by step, it's not too bad. So when I distribute this guy to this first expression, the 200 minus W's are going to cancel out. So we're going to have 3 times 800, which is 2400, times 2 plus W. Plus, then when we distribute here, the 200 plus W's are going to cancel out. So we have 3 times 800, which is still 2400. Times, oops, I forgot 200 plus W. Sorry about that. And this is 200 minus W equals, over here, just the 3's cancel out. So we have 25 times, and we can FOIL this guy together for that. So that's going to be 4 and 4 zeros. So 4,000, so sorry, 4 zeros. 40,000 minus W squared. Now if we distribute 2400 times 200, it's going to be 48 with 4 zeros, so 480,000 plus 2400W plus 24, gotta distribute, 48 and 4 zeros minus 2400W equals 25 times 40,000. Let's see, 25 times 4 is 100. So we're going to have 100 and then 4 zeros, which makes it 1,000,000 minus 25W squared. I think we might have run out of a little bit of room there. Let me scoot over. Okay. Now, let's see, we can combine like terms. So 480,000 plus 480,000 is 960,000. And these guys are going to cancel out. Equals 1,000,000 minus 25W squared. Now if we subtract 1,000,000 from each side, we have, let's see, negative 40,000 equals negative 25W squared. We're going to divide by negative 25. So that's going to be positive 1,600. Then we'll take the square root. We ordinarily put a plus or minus, right? But because this is wind speed, we're going to do the absolute value of that. So we don't actually need the plus or minus. But it's good to think about it. So what do we have? We have square root of 1,600 is 40 equals W. So the speed of the wind is 40 miles per hour. Ta-da! Alright, I hope that helps and gives you some strategy for solving these types of story problems. Good luck!